concept is finding increasing and decreasing regions on a graph by using the first derivative test. So you have a function. The first step you want to do is find the derivative of that function, and we can use the quotient rule here. So f prime at x, you keep the bottom and derive the top. So the top derivative will be 2x, and then you subtract the top times the bottom derivative. And then all this goes over the denominator squared. So then you multiply these out. So you get 2x cubed minus 18x minus 2x cubed. So you can just cancel the 2x cubed. So you get your derivative to be negative 18x over x squared minus 9. Now, you set your derivative equal to 0 and solve for x to find your critical points. So, 0 equals negative 18x equals x squared minus 9 squared. So you get 0 is equal to negative 18x, so x equals 0. And you get 0 is equal to x squared minus 9 squared.
Yeah, you want to set your denominator equal to 0 because you also want to see where it's undefined because the slope, there's no slope there.
So you take the square root of both sides and then just get 0 equals x squared minus 9. 9 equals x squared. So x equals positive and negative 3.
Yeah, so you'll always get your critical points whenever you set the numerator equal to 0 and the denominator equal to 0.
Very true. Okay, so now that you have your critical points, which are 0, positive and negative 3, you can plug these into a sign chart, which will test a point within each region. So your regions are formed in the sign chart. So you do negative infinity to negative 3. The x is going to be the value that you're plugging in within each region.
In here, we don't have any endpoints, so we just go to infinity. But if you had an endpoint of, say, the endpoints were negative 4, 4, then instead of putting the infinity signs there, you'd put those endpoints.
Yes, always test your endpoints, because those can be critical numbers too. So you'd find a number within each region to test and plug into your derivative. So, a number in this region would be negative 2. Here you could use negative 1. Here you could use 1.
Okay, you're good. Stupid phone.
Okay, now you don't need to completely solve the derivative for each of these numbers. You just want to find out if it's positive or negative. Because if it's positive, it's increasing. If it's negative, it's decreasing.
And you can choose any number between interval. So like right there for the first one, you might want to, you can't use yet negative 2 because it's not on that interval. You would have to use like negative 4 or anything less than that.
True.
And on this interval, negative 1 is between negative 3 and 0. 1 is between 0 and 3. And you want to make sure that, you see there's brackets here? Well, really there should be parentheses. You can't include these critical numbers because the slope there is 0 or the derivative is 0. So you want to make sure that they're not brackets and that they're parentheses.
Okay, now to test the points.
So just ignore the bracket.
Now to test the points, you would plug in each point to the derivative. So -4 times -18 is positive, and -4 squared is 16 minus 9, which is 5 squared, is a positive number. So we get positive over positive, so your result would be positive. Now for -1. -18 times -1 is a positive number. -1 squared is a positive number, and subtracting 9, you would get -8 squared, which is also positive. So, you know, in this region, your function is increasing. From 0 to 3, you could take the number 1 and plug it in here, which gives you a negative on the top, and then 1 on the bottom would still give you a positive. But overall, your function would be decreasing. And you can assume that because this number is squared, the bottom is always going to be positive. So you're kind of just looking for the top number. So here, 4 times -18 would make a negative number. So over positive, it would make negative overall, meaning the function is decreasing at that point. So if you wanted to write this out, you could say increasing on
And like there's no bracket on the -3 because you're not including -3 because there's no slope there.
no slope on -3.
And always remember to put the U in between your coordinates because that connects them.
Now this will be your final answer. And that's how you find increasing and decreasing regions.
What goes up